Welcome to the AI Research Roundup. I am Alex, and today we're looking at a paper from the Papers with Code trending list, published on the 5th of June, 2025. This paper introduces a new model that, despite being over 20 times smaller, outperforms massive models like Gemini 2.5 Pro on key English document parsing tasks. The paper is titled Monkey OCR, Document Parsing with a Structure Recognition Relation Triplet Paradigm. So, what the researchers are tackling here is document parsing, which is basically teaching an AI to understand not just the words in a document, but also its layout and logical flow. They propose a new framework called the Structure Recognition Relation, or SRR, Triplet. This breaks the problem down into three simple questions. Where is the content? What is the content? And how is it all connected? This approach, as we'll see, proves to be both more accurate and significantly faster than existing methods. And for anyone wanting to try this out themselves, the authors have made all the code for this work available on GitHub. It looks pretty complete, providing everything you need for a quick start. You'll find installation guides, scripts to download the model, and even a Gradio demo, which is a tool for building a simple web interface to test the model. They've also included Docker files, which are like blueprints for creating a self-contained environment to make deployment easier. Alright, and the reason you'd want to deploy this model becomes crystal clear when we look at its performance in this first figure. This chart compares Monkey OCR 3B, that's the red bar, against other leading models on a benchmark called MonkeyDoc bench. We can see different tasks, like recognizing formulas, tables, and text from academic papers. The scores are based on different metrics that measure structural and text accuracy. Across the board, whether it's English or Chinese content, Monkey OCR is consistently at or near the top. And that last bar on the right shows its inference speed, processing documents significantly faster than its main competitors. So, a big reason Monkey OCR performs so well is that it avoids a classic problem with older systems, something called error propagation. Many document tools use a pipeline-based approach, which means they process a document in a series of separate, sequential steps. First, one module detects where things are on the page, and then a second module tries to read what's inside those detected areas. And this figure illustrates perfectly how that can fail. The first step, detection, makes a small mistake, accidentally including a bit of text when boxing a formula. This error then cascades, causing the recognition step to misinterpret the formula completely. Alright, but a great model design also needs great data to learn from. And that's where the team's second major contribution comes in, a massive new dataset they built called MonkeyDoc. This figure gives us a glimpse into the sheer variety within that dataset. You can see it covers a huge range of real-world documents, everything from academic papers and financial reports to newspapers, resumes, and even mind maps. This diversity is crucial for training a robust model. And on the right, we see another key part, examples of synthesized tables and formulas, which are basically artificially created data, helping the model master these tricky, structured elements. And this figure here really visualizes that structure recognition relation framework in action. We've already seen the huge variety of documents it can handle, which are shown on the left. But the new part is the workflow on the right. First, the structure step identifies all the distinct semantic regions, which are just the different content blocks on the page. Then, for recognition, it processes all those blocks in parallel to identify what's inside them, like text or a table. Finally, the relation step figures out the logical reading order before serializing it all, which just means converting it into a structured format like HTML or JSON. So that structure recognition relation framework is clearly effective, but the real test is how it performs against the giants of the field. And this next chart puts it head-to-head with some massive models, including closed-source ones. Here we're again looking at the MonkeyDoc bench scores, with the teal bar for English and the light green for Chinese, and you can see that for English documents. Monkey OCR 3B actually achieves the highest overall performance, even beating out Gemini 2.5 Pro. For Chinese documents, Gemini has a slight edge, but Monkey OCR is still incredibly competitive, outperforming several other very large models. So it's really incredible to see an open source model like Monkey OCR not just competing with, but in some cases outperforming massive closed-source systems. This work gives us a powerful new framework with its structure recognition relation triplet and a fantastic new dataset to drive research. It really is a huge step forward for making advanced document understanding accessible to everyone. That's all for this episode of the AI Research Roundup. I'm your host, Alex. Thanks for tuning in.